Welcome to Master of Science with host Professor James McCanney. The good professor's career spans 50 years as a university teacher, scientist, and engineer. Each week, he will explore the rapidly changing world of science as many long-held theories are crumbling under the weight of new data. He will cover the fields of geology, archaeology, meteorology, oceanography, space science, astronomy, cosmology, biological evolution, virology, energy, mathematics, and more. So please welcome the host of Master of Science, James McCanney.
Good evening, everybody. Tonight I'm going to talk the main science topic, that is, about pole shifts and the effect that these have on planet Earth, but also how they are not explainable by your standard set of explanations for things. So that'll be the main science topic. Very important. I've talked about the mechanisms of pole shifts, but the importance of understanding this from an archaeological point of view, anthropological point of view, very important, because after decades and decades of different groups trying to explain what's been going on planet Earth, the real explanation is that the pole shifts are very important, and there's only one way to have a pole shift, and that is with a outside interference. Let me quick explain this a little bit. I'll just, and then I've got a couple quick announcements. But imagine you're a gymnast. This is the best way to explain it from a physics point of view. Imagine you're a gymnast and you're in the gymnasium. There's various forms of, there's the rings where you hang from the rings and do exercises and flips, etc. There's the parallel bars. There's like a wooden bar, the single bar, and they do exercises. And then there's the mat where they tumble and do gymnastics from on the mat. Okay, what is the one requirement for all of these? And that is some other form of resistance, some fixed platform, or in some cases movable platform with the rings, to work against. If the gymnast were out in outer space, free in outer space like the Earth is, if the gymnast is in outer space and has nothing to push against, then their angular momentum will be the same. Their angular velocity could change, because if they were spinning, they could pull their arms in, it would make them go faster. If they extended their arms out, they would go slower, but their angular momentum would be a constant, and there's nothing out there to change it. And so, anyway, okay, I'll talk more about this in a minute, but first a few announcements. The wind industry has gotten kind of a free ride, let's put it this way, from the news media. So the news media has given the wind industry a free ride, basically. So there's a lot in the news regarding wind energy, the bad stuff that is going on daily, communities around the country, around the world, and other countries fighting for a piece of just normality. I talked about the time I went through, northern Indiana. Oh my goodness, thousands of these three-blade wind turbines are not doing anything. They're just sitting there. And the lies that they use to sell these, and the money under the table to buy politicians off so that they push these projects through local zoning or whatever it takes. But yeah, so there's the whole ugly side of wind energy you don't see. And if you're a green tree hugger, which I am really myself, I'm a tree hugger. I love nature, I love to preserve, etc. But the idea that these monstrosities somehow produce energy and they're going to reduce our footprint, oh my goodness, what a lie. It's like the lie of nuclear power. that I just saw another one about thorium. Oh, it's going to save us. No, there's no form of nuclear power that is good. It is just simply that way. And one of the biggest reasons is that it just pumps heat directly into the atmosphere. You have to cool these things down. And so the idea that nuclear power does not generate CO2, making it green, no, not at all. The nuclear industry is one of the most foul, polluting forms of energy ever invented by man. Albert Einstein, when asked about it, he said, using nuclear energy to warm up your coffee is not a good idea. That's pretty much what he said. Okay, so back to the wind energy. What I'm going to try and do here, let me see if I can pull some of these up and read some of the things going on here. Okay. Here's an interesting one. Wind, and this, by the way, comes from an organization called National Wind Watch, and you can get on their mailing list and get this mailed to you every day. Here's one where wind farm developers are pulling out of contracts that they've had. Now, these things take decades to, in some cases, to push through, to get all the approvals, to get all the everything. And they are saying here that the wind turbines require a tremendous amount of steel, copper, aluminum, and all of which have tripled in price in the last couple of years. And so there's other costs like the high voltage cabling, the magnets in the turbine generators themselves, and geopolitical issues, not only financial costs, but other types of costs. But these companies are pulling out of their obligations to provide to build the wind farms. Here's another one: Golden Eagle collision fears raised over wind farm plan. So a pioneering project to boost Golden Eagle numbers in the south of Scotland has raised collision risk concerns about a wind farm planned in the borders. So anyway, there are people who have these built in their backyard, and oh my goodness, what a disaster. They can't sleep, their property value goes down to zero, and the county board or whoever pushed this through, these projects, the people lose their life savings, because most common people's life savings is in their house. That's where most of their invested money is. And if they're older, and they've fought these battles in court and just consumed their life trying to resist these organizations, these companies, from putting in three-blade wind turbines, because when they put them up, then they don't work. Here's another one of the, I would say, the central big lie that is given by wind energy companies when they come into a region to install wind energy, is they say, oh, well, this will power 700,000 homes, 1 point something gigawatts of power, and they don't produce that. Usually not even a tenth of that. And so they put in this investment, but what are they really after? They're after the government incentives, the tax incentives, and that's where the real profit is. And then after a year or so, they sell off the hardware and all of the contracts, etc., and leave, and then nobody's responsible for the maintenance, or eventually, the worst case is when eventually these things go out of commission or become they are in disrepair. Nobody comes out to fix them because it's too expensive. And so the people are left there with these monstrosities, and what do? The base of these things in cement covers like a quarter acre in rebar and cement, and then this tremendous steel tower 400 feet high And then there are things like when the blades turn around and cause a shadow. So you're in your house and every 3 seconds a shadow flips through, and it's a psychological thing. Or the noise, the electromagnetic humming noises that come out of these things. So people can't sleep. They cannot sleep at night. It's a horrific situation. Now, this was planned. The entire failure of the wind energy industry was planned decades ago, and I talked about this in my book published in 2010, McCanny Wing Generator World Energy Project, where I show that my patented trademarked wing generator does not have any of these bad properties. But what's going on? These large corporations get the government subsidies. They make rules that favor them so that only installations can be installed that meet certain government standards, and they're on the boards of the government organizations, so they prevent anything that really works from coming into the market. I've talked to people in the Department of Energy, for example, people who have no idea what they're really talking about. They're supposedly physicists, but they were trained decades ago, and their job primarily is to fast forward the installation of three-blade wind turbines. It's a horrific situation. So in Canada, also, they had to fight this around the northern edge of the Great Lakes. Canada installed hundreds of thousands of wind turbines, and in those numbers, literally. And the people tried to stop it, and it was all subsidized by the Canadian government. But the end result was it never produced energy. So the promise was that everybody's energy prices would go down. The end result was that everybody's energy prices had to go up because they had to pay these tower installers, these companies that install these wind generators, three-blade wind turbines. They had to pay them in some cases $1 million a year per tower. And this all came out of the money generated from people paying their electric bills. So not only did they not get the nice, clean, free energy, but they had to pay a lot more for the energy they got because of this. And this is all over the United States. Also, you find that the power companies that invested heavily in three-blade wind turbine technology, the prices of their electricity went up. And basically the installations never met the fanfare that they were given. So anyway, the end story here is that the news media has covered. They have, just like I talked about last week and other prior weeks, I talked about science, how they, for example, YouTube and other outlets, other platforms have pushed certain agendas, or let's say Wikipedia, etc., in terms of science, and then shadow banned others so that the public does not have visibility of what's really going on in outer space and astronomy, astrophysics, and then push the agendas of, for example, the Big Bang or the whole laundry list, dark matter, dark energy, all the nonsense that is passed off to you, the public. And the news media is complicit in this, in that they promote certain things and they shadow ban other things. Okay, so at any rate, important to understand that three-blade wind turbines are, here's the thing too, that when people get wind of this, then it seems like the news media is able to cover their tracks. Maybe they go silent for a while and everybody thinks, oh, the issue has been resolved. And all of a sudden they come back. And that's in terms of science. Remember that here's another example the James Webb Telescope came out taking photographs of fully blown, fully developed galaxies, farther away than what the Big Bang was supposed to be. And so the James Webb Telescope is seeing not newly developed galaxies, but old galaxies, structural galaxies at a distance farther than the alleged Big Bang. Farther means farther longer ago in time, a longer period of time in the past. And so everybody came out, and really, I'll be honest with you, being in the scientific community, the vast majority of scientists out there, physicists, astrophysicists around the world, don't believe in the Big Bang. Many of them never did. It just had too many, there was just too much silly science, too much hand waving, and so it was this small core group of people who are getting the funding, and this is what it comes back to. The same way with three-blade wind turbines, the same way with astronomy, the same way with astrophysics, that the core groups getting the funding keep getting their funding, and they have a way of manipulating the news media. I talked last week about the ever-growing number. Just every week I see more and more YouTube channels, some of them by complete amateurs, all the way up to people with PhDs in astronomy or astrophysics, having a channel on YouTube talking about standard science, all of which is just completely bogus. But they highly promoted, and these channels have not been around that long, and you think, well, how could these channels gain this much notoriety this quickly? And that's because they're promoted. They artificially put numbers on these channels, and then they take off because the algorithms pick up. They go, oh, everybody's watching this, so then they send it out. For example, when you're flipping through your phone, looking at shorts or video shorts or TikTok or one of those, they are tracking what you're looking at. So if you are interested in astronomy or astrophysics or space-related items, they start feeding you more and more of these. And the end result is, though, anything that criticizes standard science is being shadow banned, and anything that supports standard science is being promoted. So people, it's a way of programming the public to believe standard science. Okay, I'm going to talk about a couple of examples recently in the news this last couple of weeks, dealing with what I call circular reasoning. Circular reasoning is when you assume a concept, you go get data, you interpret that data to support the concept, and then you say, well, after a while, it's just you keep repeating the concept until it's assumed to be true, and nobody else can offer. Here's the problem with peer-reviewed journals, is that nobody else can offer an alternative solution once the main theory gets in there. So as a result, like I said, this idea that the planets formed from an accretion disk 4.5 billion years ago was developed in the 1700s. The Laplace, was developed by a guy named Laplace in the late 1700s, and it doesn't work by any stretch of the imagination. But now you have people making measurements, and here's a good example. So I'm going to actually show what they did in the experiment, and they're touting that they in fact have learned more about their process. Let me see here. Oops, I'm in the wrong. Oh, okay, here, sorry about that. It's called ALMA. It is the Atacama. This is in the Atacama Desert in South America. Atacama Large Millimeter Submillimeter Array, called ALMA, the findings published in a dedicated issue of the Astrophysical Journal. And now what they're claiming, let me just read some of the findings here. It says that protoplanetary disks endure for several million years around young stars. Well, first of all, they haven't been observing for millions of years. That's an assumption. So do you see how they make a statement, and it's not based on any kind of science at all. It's an assumption. But after they repeat it enough times, it becomes a scientific fact. And then also that says that their changing gas and dust content determines what kinds of planets form and how they evolve. The disk's initial properties of mass, size, angular momentum shape the architecture of the planetary systems. But what they did, now what I want to talk about here, is what did they actually measure? Did they actually measure something that proves their theory? No. What they did is they looked for trace elements of gases. So we have carbon dioxide, carbon monoxide, water and carbon compounds, DCN, DCO, N2, let's see, a carbon hydrogen chains, hydrocarbons, and they examined 30 stars that have these, what they call protodisks around them. And at any rate, the issue is that if you look at what they actually studied, they took readings from spectrometers and identified gases. Okay, good, because prior to that they had only been able to identify solids. And then their conclusion is that, let's see, where the advancement of science is truly collaborative endeavor driven by different people from different countries. And then one of the guys says, the study revealed that gas often outlasts dust in an aging disk, resulting in a shift of gas to dust ratio. Well, I talked about the fact that these are volatiles, and when these planets allegedly are forming from a disk, they are extremely hot. And so there's no way for atmospheres or water, liquid water, or any form of volatile hydrocarbons, etc., all the way up to sulfur in the periodic table. None of those elements are in the planet because it's just too hot. They get baked. They're volatiles. They escape from the heated planet, molten planet, and they never come back. And so observing them really would tell you that, gee, the atmospheres come from some other source. You have these various gases there, but they're not going to be part of the initial planet, and that's the reality. But they assume that, they just assume that somehow these forming planets adapt this material to become atmospheres. But if you look closely, they did not observe that, because they're only observing the presence of these volatile chemicals in the dust clouds that surround stars. So once again, it's silly science, and these people are being paid. And why am I telling you? Because you are the ones paying for this nonsense. But these people touted as a great advancement in science. Okay, now here's another one, and this is this past week. This is from Princeton University. Princeton Plasma Physics Laboratory has a new device in which they talk about something called magnetic reconnection. And now I've been at meetings where scientists are talking about this supposed concept of magnetic reconnection. And what happens is magnetic field lines seem to break and then reconnect. And the problem with this is that magnetic fields simply don't exist in outer space and plasma environment of outer space. The magnetic fields simply don't exist, and if they did, they would be very short-lived. The only reason magnetic fields exist in outer space is because there are electrical currents that drive them. And this is simple Maxwell's equations, the electromagnetic laws of physics. That when let me explain something here. If you have a motor, let's say on planet Earth, you have a motor. What happens? You have electrons that are moving through a wire. They're contained in that wire. It's like the electrons can't leave. So they're able to exert a force when they encounter a magnetic field. In the plasma environment of outer space, when charged particles move relative to a plasma, they're not locked into a wire, and so they cannot. The rules for example, making electromagnetic motors or induced magnetic fields, they work very differently. And these people are people at Princeton, and they don't know this. Absolute nonsense. And so this concept of magnetic reconnection simply is absolutely incorrect physics. Yet they're building some kind of a device and touting this as being some kind of an advancement for physics, when in reality, once again, the point of pointing this out is, number one, you're funding this nonsense. Number two is that it's circular reasoning. They don't understand plasma physics. They don't understand that electric fields are necessary to drive magnetic fields in outer space, in the plasma environment of outer space. And so they make up a term called magnetic reconnection. And to explain how these magnetic fields supposedly just self-exist on their own in outer space with no means of formation. They can't tell you how they form or how they exist, how a magnetic field exists in the plasma environment of outer space all by itself, and continue to do this for millions and millions of years. Okay, so at any rate, the reason this is important is because standard science, this is tier 2 level standard science because it's published in peer-reviewed journals, is really a mockery of science. And when you pull back only the first onion layer, you find that they don't work. And the problem is, both of these, all three of these things, I talked about the wind energy situation, I talked about accretion disks, another concept in astronomy, and I talked about magnetic reconnection. None of this would exist if it were not for the government funding. The government funding, and how does that work? The people who administer the government funding have worked their way up through the ranks to, graduate school, PhD, postdoc, first maybe working in a university, maybe working for a government agency, working their way up to finally they're at the point where they're in charge of distributing money from, say, the National Science Foundation or NASA or one of the 3-4 letter agencies, government agencies, NOAA, the National Oceanic Atmospheric Administration, etc. And what do? More of the same. They push the money down to the places where they are educated. I call them textbook geniuses because they have studied in textbooks and they've learned everything in the textbook, but what they don't realize is that 99% of what they're spouting is completely false. Okay, I want to talk just a second about the cost of wind energy, and this would be from the perspective of the central power company. In other words, okay, they go out, they buy equipment, they buy the 3-blade wind turbines, they go out and install them, they start feeding energy back into the electric power station, it goes out on the grid and then is delivered to you it mixed in with other sources of electrical energy. Okay, so what is the cost per in the electric companies talk in terms of megawatts, megawatt hours of power? When you pay your electric bill, for example, you pay in terms of kilowatt hours. And so that's the number I'm going to use to compare. So the average, for example, in Texas, let's say, the average cost to the homeowner, industry, by the way, gets a cheaper rate because they're buying in bulk, but the average homeowner might pay 5 cents per kilowatt hour for electricity. Okay, other states might be higher, 10 cents, 12 cents, but the lowest rates are typically around 5 cents per kilowatt hour. Okay, so that would be around, so let's take a look at the cost of wind energy now. Now there are estimates and people that do estimates for the cost of wind energy, and some of them come in at something like $80 per megawatt hour. Then 1,000th of that, take that number divided by 1,000, and then you end up with the cost per kilowatt hour. And so the more realistic estimates from the ones I've seen come in at around $150 for 1 megawatt hour of energy. So you divide that by 1,000, you move the decimal point over 3 places, and you come out to around 15 cents for a kilowatt of power. And this is what the power company pays for the wind energy. And so it's more than the retail cost of electrical energy from other sources in pretty much all the other states. And so so that turns out to be about 15 cents per kilowatt hour. And so that in a place like Texas, that turns out to be about 3 times. In other words, I'll say this specifically, that turns out to be 3 times the wholesale price of wind energy electricity is about 3 times that of the retail cost to the consumer of electricity. So clearly, this has to be subsidized for it to actually work in the economics of the situation. 15 cents per kilowatt hour for wind is more, once again, than probably every state in the union. So it's not green energy, it's very expensive. However, it is not average in the couple factors. One is that when the wind is blowing, sometimes, and there's a lot of production, there's no demand. And then there's the flip side of that, when there's a lot of demand, the wind is not blowing. So there's a mismatch there between what is being produced and the demand that's on the grid. And so what they'd have to do is constantly make up for this. Another big problem is what are known as surges. Excuse me. So you have a gusty day, and so the bigger the problem becomes, the more wind installation you install. So if you have more and more wind installation on a gusty day, the wind turbines are variable. And so how do you make up for this at the power station? Well, you simply don't. So what do? They shut it down. They turn them off. They rotate the blades into the wind, and they just shut them off because they can't deal with the variability that's coming from the wind part of the energy production. So that's another factor. One of the biggest factors is simply downtime, that the 3-blade wind turbines, once broken, nobody's running out there to fix them. The typical thing that breaks might be the blades. The most common downtime is caused by the transmissions. And so what happens, you have something moving very slow, which is the blades, and then you have the generators, the electrical generators that typically are around 3,600 RPM. That's a typical generator RPM for the grid that we live in the United States. And so that gear mechanism, it's very difficult to take something from a high power source and low RPM and move it to a high RPM generator. It's a very difficult thing to do, and so a lot of them break. In your automobile, for example, you have a high RPM engine which goes to a relatively low RPM transmission that goes out to the wheels of the car or the truck, whatever. And so you have the opposite situation where you have maybe a 3,000 RPM, 3,600 RPM engine driving wheels that are in the maybe 10 or 20 RPM range. And so it's the opposite, and that works very well. There's not a problem with that. But in the world of mechanical engineering, going from low RPM, high power, high torque sources to a high RPM load is a very difficult thing to do. And so it turns out that they end up failing a lot. And so the estimate for 15 cents per kilowatt hour wind energy does not take into account the failure rate. So it's much higher than that. So the actual cost of wind energy is extremely high. And then you take into account, they don't take into account, for example, the loss of property value of farms, of residential property, that the property lost because the wind turbines are in the backyard or nearby. They don't take that into account. So the overall loss for wind is horrendous. And then you have the environmental losses, the amount of metal that has to be put into them. Essentially, they will never ever pay for their footprint. Just to put them there, and then you take the average life of a 3-blade wind turbine, it will never pay for itself, let alone give a payback in terms of electricity. So where does that extra money come from? Well, actually, it comes from you through government subsidies. Okay, so just to give people an idea of cost breakdown. And when you hear people, if you hear somebody saying, oh no, and because this could be criticized by people that think they know what they're talking about. If you hear anybody saying that electricity from wind costs less than 15 cents per kilowatt hour, they don't know what they're talking about. They're not including all the factors. In fact, even at 15 cents per kilowatt hour, it's not including all of the factors. Okay. Just a quick other mention here about artificial intelligence. Last night I was on Coast to Coast AM radio show talking about this. It's a subject I talked about on my September 10th, 2024 show of this series, the Master of Science television series, the show September 10th, 2024. I talked about artificial intelligence and the failure of AI. And just to be clear, AI has really never been developed. In other words, artificial intelligence, everything that's being developed today is basically what we call in the industry relational databases. In other words, you call up some automated engine, answers the phone, hello, how are you doing? Or they're calling you up, they're doing telemarketing with AI now. Hello, how's your day doing? I'm sure you've all gotten these calls. I just wanted to talk to you for a minute to see if you needed help with your insurance, with your taxes, with your whatever it is, your eyesight, see if you qualify for a certain program. And it's some AI voice calling you up. And they want to engage you in a conversation, and then if they can get an engagement, oh, well, I'll hand you over to one of our specialists right away. So then they have a team of real people sitting there waiting to take these calls that have already been pre-screened by an AI call agent, whether receiving or calling out. But those are relational databases, because based on what you reply, they're going to come back with another reply to you. And it's based on, they might have 5 or 10 things that they can say back to you based on what you say. They say, "Hi, how are you doing? Having a good day?" "Oh, yes, I'm having a good day." "Oh, well then, this is the perfect time to talk to one of our agents." And they have all of these canned, they have all of these canned responses, but that is a relational database. Okay, now on to the main science topic, about 20 minutes left. And basically talking about pole shifts. Now, there's a lot of confusion, and some of it might be intentional, and I think most of it is out of complete ignorance. And I've seen this even from people who are trained physicists, who supposedly you might think would know better. But at any rate, there are two types of pole shifts. Let's start out with the fact that Earth and the Sun and Jupiter and other planets have two types of poles. They have the magnetic pole, which is the pole of a magnetic field. If you look at a map of a magnetic field or magnetic field lines, they have the North Pole and the South Pole, and the grid work looks something like this, with the field lines coming in at the North Pole and the field lines coming in at converging into the South Pole. The physical pole of the planets, of the Sun, Jupiter, Earth, is a little bit different. It's the physical rotational pole. So if you put a pin in the Earth, in the North Pole and the South Pole, that's the pin around which the Earth spins. So that's the physical pole. And so the magnetic pole is different. In fact, the magnetic pole is off by, a good 1,000 miles or more. It's a couple, I forget where it is right now, and it's moving slowly towards the physical North Pole. So the magnetic pole of Earth and the physical pole of Earth do not align. Jupiter is much more closely aligned, and that's because its magnetic field is aligned. The alignment is caused by the actual spinning of the planet, whereas Earth's magnetic field, a lot of it is contained in the crust and mantle in the form of permanent magnets. But when you get outside of Earth, then you have you have the plasmas, which then couple together to create Earth's magnetic field. So a magnetic reversal, typically what happens is the Earth does not just do this by itself. What happens is there is a magnetic field that's locked into the solar wind, and this is a wind of charged particles that are coming out of the sun. And so they can have a northward magnetic field, or they can have a magnetic field in many other directions, including completely rotated to the southern direction. So sometimes the Earth is hit by a reverse magnetic field in the solar wind, and it's strong enough to actually flip our magnetic field temporarily. And you can actually measure this with a little handheld compass. And this happens regularly, maybe a couple times a month, where we get a jolt from the solar wind changing our Earth's magnetic field, etc. And so it's a common event. And it does not, I repeat, it does not cause the Earth to juxtaposition its surface or anything else. It might give a little bump or something like that, but it's not going to move anything miles or even hundreds of feet. It's just, but the physical pole shift is something very different. There's a lot of angular momentum locked in the crust and mantle of the Earth and in the rotating core. Now, Earth is built something like an egg, a soft-boiled egg, let's put it that way. And so the inner core is spinning with the outer mantle and crust in a normal condition. But if you could take the mantle and crust and shift it quickly, then the inner core would continue to spin in the same direction because it's not connected. It's like a a soft-boiled egg. In fact, there's an experiment, very simple one that you can do. You take an egg, a hard-boiled egg, and you take a soft-boiled egg, and the question is, how can you tell the difference between the hard-boiled egg and a soft-boiled egg? They look the same, but if you spin them on a table, the hard-boiled egg continues to spin, whereas the soft-boiled egg stops very quickly, and that's because when you initially spun the egg, the center of the egg, the liquid part, did not spin because it's not attached to the shell like it is in the hard-boiled egg. In the hard-boiled egg, the inner part is solid and it's connected to the crust and the shell, and when you spin it, the whole thing spins inside and outside. But with a soft-boiled egg, or just a raw egg, when you spin it, the inside does not spin because it's not connected to the shell. You're spinning the shell. And so when you spin it, the inside does not spin, and so what happens? The viscosity between the inner part and the shell interact, and it slows down very quickly. So just try it out. The earth is like the soft-boiled egg. The internal molten part of earth is a viscous layer, and then the crust is over the top. Now, what happens if a large celestial object comes by, high velocity, sends a gravitational wave into the surface of the earth, and it's not connected to the core? Well, it can shift over the inner part of the earth, which continues to rotate the same direction it did prior to the pole activity from the passing object. And these have to be big objects. So we're not talking about little asteroids here. We're talking things the size of basically our moon and bigger. And the fact that we see the remnants of these pole shifts, the physical pole shifts in the Earth's mantle and crust and on the surface, for example, a good example is the Laurentian ice cap, what they call the Laurentian ice shield. And what happened is it was centered around Hudson Bay. And so that's where the old North Pole would. A guy named Hapgood explored this, and that's how he determined where the center of the old physical North Pole was. And he said that he found all kinds of evidence for the fact that the Earth had pole shifts. And Velikovsky found this. There's our people today like Mark Gaffney, Mark Carlotto, and myself. I did surveying myself in Mexico at Chichen Itza, Uxmal, Tulum, on the ground with surveying equipment long before Google Maps was available, and determined that the cities, the Mayan cities, were built on the old grid work, and if you triangulated them, the old North Pole of Earth was somewhere in Hudson Bay, agreeing with what Hapgood did a long time ago, and he was ridiculed. Now, what other telltale signs are on Earth that are indicative of a pole shift? Well, one of them is plate tectonics. One of them is mountain building. That's what causes mountains to be built. When the gravitational wave comes in, imagine a land wave. I'm not talking about an ocean wave now, but imagine a land wave that's 1,000 feet high and moving at around maybe 1,500 miles per hour as this large object comes by. And that energy, when that wave hits an existing impediment, like an existing mountain range, it crashes into it, and that's where the upthrust mountains come from. Also, volcanic activity. Also, coal mines. Coal mines is a perfect example, or coal deposits, I should say. It's a perfect example of tsunamis. These are tsunamis, the kind that you don't see on Earth, where Earth does this all by itself. No, these can only be created by massive sea waves that come in, rake up all of the material, the vegetation material, and deposit it on the lower side of a mountain. This is what you find in Appalachia, the coal mines in Appalachia, or in Pennsylvania, the same thing. You find, what are some of the other effects that accompany the pole shift? For example, the influx of water from the comet tail. These objects would be in the form of large comets, and also the hydrocarbons. The fact that Earth is just laden with hydrocarbons, what we call oil, and the ancients talk about this. They talk about the brimstone and fire, the rain of fire that came in and it would burn the skin. Because how did this ignite? Because the oil, the hydrocarbons were coming in, and as the meteor streams came in and ignited in the atmosphere, it would literally light the hydrocarbons on fire. So that's where the rain of brimstone and fire came from in the biblical accounts. There's my latest book. It's called The Real History of Man and Earth: Myths, Magic, and Mayhem. Available on Amazon. Also available on my webpage. And so you see all of these different effects. You see, for example, the mastodons that were temperate climate animals in what we now call Siberia, flash frozen, and all of a sudden the northern tundra moved. The Arctic Circle now encompasses what we call Siberia, which was not within the Arctic Circle at some point in history when the mastodons were roaming the Earth. All of these are effects of a large passing comet. And I talk in my weather book, the Principia Meteorologia, the physics of sun-Earth weather. I go through all of the different Earth effects that happen as a result of Earth encountering a large passing comet. The other thing is that the atmosphere can change drastically. The ocean levels can either rise, or there have been events in Earth's past where the oceans in the atmosphere have literally been taken off, just like they did with Mars. The universe is a very violent place, and man has survived on this planet multiple times through multiple events. And the thing is, the reason I'm bringing this up, because you continually find people running around jumping up on the internet, jumping up and down, saying that asteroids hitting Earth could cause this. Well, number one, if an asteroid caused something, you're going to see a crater, and a big, big crater, not just some little mealy mouse hole in the wall. It's going to be a big crater, and you don't see them. And it would take a very big crater to make the kinds of changes that we see. The Earth changes. It would take an extremely big asteroid. And so where's the crater? They're just not there. That's not to say that asteroids have not hit Earth. Yes, they have. But when we see this repetitive damage to Earth, the Noah's event, the Noah's flood, the Venus event where Venus came by, and that was a cause of mountain building and a physical pole shift. And there have been a number of them. Hapgood, in his studies, discovered quite a few pole shifts. Mark Gaffney also discovers that. Mark Carlotto also discovers this, that there were many pole shifts, not just one. So that means repeatedly Earth has been attacked by, who knows, we don't have a history. We don't have a history of the events that have happened with large passing comets. Okay, so the reason for talking about this, I've talked about pole shifts before. I've talked about the physical aspects of pole shifts and how it works. Sometimes I repeat things because it's a teaching technique. You have to repeat things 3 times for people to actually pick it up. I've learned that from teaching even in the university. If you have a really important point, it should be mentioned at least 3 times. But the point is that the effects that we see on Earth, you look at the effects overall, You can't just take one of them isolated and say, well, this is proof of a pole shift. But you take all of the evidence, and it's very clear that the pole shift, the physical pole shift, has been the primary, let's say, major physical event on planet Earth that has affected man's history, and not colliding asteroids. And I think that's one of the biggest important points to walk away with, because so many people are trying to promote this asteroid hit Earth type of thing. And that goes along with the mantra of Earth doing everything by itself. Because Earth just cannot do what we've seen, cannot do it by itself. And that's why I talked about the gymnast in the beginning of this discussion, is because Earth cannot just all of a sudden juxtaposition its crust all by itself, or because some people think, oh, well, it snowed more on this side of the Earth, so the Earth flipped that way. No. It has nothing to do with the actual physical situation. The effects are so grandiose, so great, that the average the effects that we see could only be caused by something large passing by. And I want to emphasize that I'm not aware of anything that would be coming in, and this is what we call the Planet X type objects. The NASA has gone through contortions to first remove Pluto as being a planet, so that when they talk about discovering another planet, they can say, oh, that's planet 9. They don't have to mention the planet 10 scary word to the public. And so they had to demote Pluto as being a planet, so that they could go now, and as they discover these literally thousands of new planets, they can talk about planet 9. It's just a joke. But that's how afraid they are of letting the public know what's really going on out in the wider universe. Outer space is a very cruel place, a very unforgiving place. And I talk about this in my books, in that the cosmos, let's say forest fires, there's all kinds of natural disasters that are devastating, but out of the ashes grow an entirely new forest. And it's the same way with planets. Mars right now, it lost its atmosphere and oceans. A number of thousands of years ago, it was actually witnessed by people. They talk about it, and the Earth has gone through similar things. You can see where Earth went from potentially like the dinosaurs, for example, and the Earth's atmosphere changed drastically. So you have the atmosphere, the water levels, the amount of water, the amount of oil, the amount of other resources, coal, for example, on Earth. Coal is something that's a real indicator of this type of activity with physical pole shifts. So at any rate, I encourage you to read my new book, and very shortly, if not by this show, we'll have the I'm not sure if they're up yet, but all of my books will be on a library, both on my webpage and on Amazon. So go to the webpage, jmccsci.com, and just wanted to let you know that there's a huge sale going on, pre-4th of July sale, with the jmccwaterfilters.com webpage. Go there for literally like 50% savings. If you want a whole house water filter, now is the time to purchase. Normally like $1,500, now in the sub $1,000 range for a complete setup. And you can have the plumber come to your house, install them, and you have clean water. But all of that information is accessible from the one webpage up here, the jmccsci.com webpage. So good night, have a good week.
This has been Master of Science with host James McCanney. Join us each week as James will delve into historical figures such as Nikola Tesla, Albert Einstein, and the great mathematicians as we explore the history of man, Earth, and our universe as you've never seen it before. Tuesdays, 7 p.m. Eastern,